made mention of data exploration or sometimes we call it data pre-processing. Okay. And we also talked about data collection. Collection. So this is like the data science lifecycle. Um, right? We understand how the life cycle works basically now. So if we can remember correctly, we made mention of this part of the data science life cycle that we do advanced techniques, and the part basically we talked about was the predictive analysis part. So this predictive analysis. So usually within the data science life cycle, the predictive analysis is at that point where we perform different machine learning operations, right? So the question here basically is, what is machine learning, right? What is machine learning? And so what is this machine learning? I know most of us might have heard it, and as well been exposed to what machine learning is. I think for you, Luwashion, you've at one point written machine learning codes as well. But this is what it means basically. So the most explicit definition of machine learning basically is the ability of a machine to learn without being explicitly programmed. So what that means basically is that we have a machine, right? For example, this is a machine, right? And we give the machine some set of data, right? Give the machine some set of data, and we say, oh, this machine learned from this data, right? It learned from the data, basically. So this is what happens, right? This machine basically picks up all of this data, right? And what it does to this data is that it looks into this data, right? And it helps you to look for the different patterns within this data, right? Look for the pattern within this data. So say for example, right? For example, okay, you have a machine, right? And you're telling this machine that, oh, help me prepare a meal, right? But what do you give to this machine basically? You give the machine some set of ingredients, right? You give the machine some set of ingredients like this, right? So set of ingredients. You say maybe you want to make rice, for example. Give me rice, you give it tomatoes, you give me onions, and all of those. And after giving this machine some set of um, ingredients, what you then give the machine next is that you give the machine what the food should look like at the end of the day, right? Give it what the food should look like at the end of the day, right? So you give it so many food. You can give it like maybe 1 million examples of food, 1 million examples of food and different ingredients. So what this machine does is that it picks up this whole ingredient, for example. It picks up the food, the different examples of food that you gave it, and it learns, right? Oh, what does it take to make this food? You also give it the set of instructions, right? You give a set of instructions on how to make this food. So you give it like almost three things, right? You give it set of ingredients, you give it set of instruction on how to make the food, and you also give it an example of the food, right? So what the machine does basically is that it understands all of this particular, this particular process basically. It understands that, oh, there's a set of ingredients, it understands that there's a set of instruction to cook that food, and this is what the food will look like. So it learns from this particular data. All of this is data. It learns from this data, right? So that in the future, right, if you tell this machine that, oh, take another food, right, the same food, right, take it, or you give the data in the future, take some ingredients, right? You give it some ingredients and you say, oh, just cook food for me, right? What it does is that it already understands the different pattern in which you use to prepare this particular food, because you've given it some examples of some set of instruction. You've also given it what a typical rice should look like. So if you give it another set of ingredient, for example, what it does that it's intelligent enough to know the set of instructions that it will use, and it's also intelligent enough to know the kind of food it's going to cook basically. So another example basically would be let's say a spam filter example. Let's clean this off. Right, a spam filter. So how does a spam filter works? Right, so you have, this is your inbox, right? Usually when you send mails, you have inbox, right? You have your inbox, maybe in your Gmail, maybe in your Yahoo, or anywhere. And in this your inbox, you receive messages, right? So different kind of messages sometimes that you receive. Sometimes the messages they go into your spam, right? Some of them go to your spam folder, right? And some of them also go to your normal inbox, right? They come into your normal inbox sometimes, right? So the question is that how does this inbox know which of the emails that are coming in are spam emails, right? Or which of the emails that are coming in are normal email? So what it does is that there's a spam filter somewhere, right? And this spam filter is just there filtering all the emails that are coming in. So emails are just coming in from different angle. They are coming into your inbox from different angle. They are coming, they are coming like this, right? So when they get to your inbox, before they get to your inbox, they will meet this spam filter, right? This spam filter. When they get to meet this spam filter, what the spam filter does is that it checks that, oh, okay, this particular mail that is coming from here, is this mail a spammy mail or is it a normal mail? It checks this one too. Sees if it's a spammy mail or a normal mail. It checks this one too. Is it a spammy mail or a normal mail? It checks this one, and that's how it checks all of the emails that comes in. So the question basically here is that what metrics or what algorithm is this particular spam filter making use of in order for it to intelligently identify which of the males are spammy or which of the males are normal males, right? So that's one of the use cases of machine learning, right? And I'll explain to you guys in a minute how this spam filter works or what are the kind of algorithms that will make use of in writing spam filters, machine learning models. So that's basically what machine learning is, and a quick snippet of you know the flow in the machine learning model basically. So just like I said earlier, machine learning is just the ability of the machine to learn from data without explicitly program, right? In some books, just like in the O'Reilly book, it's been defined as some set of instructions, right? Or the ability of a machine to learn from an experience E, right? With some set tax T, and as well in respect to a performance P. I know you guys might not understand what I'm saying right now, but I'll refer back to this definition later in this cycle, and you will then understand what I mean by experience E, tax T, and performance P. So let's clean this off. Okay, and we can briefly talk about the different categories of machine learning that we have. Okay, all right. Take this off. Okay, delete this, delete this. Okay. All right. So yeah. So moving forward, let's talk about the different types of machine learning models. Okay. So we have three major categories or types of machine learning models, right? Types of categories, right? So the three major categories, we have one of them which is the supervised or the unsupervised machine learning model. So we'll start with the unsupervised. Unsupervised machine model. And we also have the supervised machine learning model. And last on the list is the reinforcement learning. Reinforcement learning. So these are the three major categories of machine learning models. So we'll be explaining these different categories one at a time, right? Quickly, because we also need to cover other topics today. All right. So yeah, let's start off with the supervised machine learning. So what are supervised machine learning models, right? So supervised machine learning models, these are machine learning models that have been trained with labeled data. So what do I mean? So for example, right, I have a machine learning model like this, or let's say a machine, right? And I need to feed this machine with some data, right? But the data I'm feeding this machine with, basically, right, has to have some sort of label to it, right? Just like when you go to a shopping mall and you want to purchase something, most times you'd want to see a label of that thing and the price tag, right? So that you know where you're buying in the point in time, which makes it easier for you. So same thing as a machine learning model. When you are feeding it with data, right? So remember, we always need to feed it with data so that it can learn. Just like I explained earlier, part of the definition of a machine learning is for it to learn properly from data. So without data, your machine will not be able to learn anything. So the question here is that this particular data that you're feeding in your machine, is it going to be labeled or it's not going to be labeled? I would explain further what it means in the real world by labeled and unlabeled. So when you give your machine learning model some sort of data that are labeled, it becomes easier for the machine to learn, right? Because it knows that, oh, this particular thing is labeled and I know it, right? So what technically does this label means? Okay, so this is what it means technically. So for example, just like I explained with the spam filter earlier on. So a spam filter basically, right, is a machine learning model, right? This is a spam filter that takes in two different kind of data, right? It takes in spam data and it takes in normal data, right? So if you are training this kind of model, what you do is this is your model, right? This is your spam email. This is also your normal email, right? So what you are doing is that you are giving this model, you are giving it, different examples of emails that look like spam, different examples of email that looks like normal email, different examples of spam email, different examples of normal email. We all know the different examples, some of the examples, right? Possible examples of spam emails. Sometimes you might see in your inbox that you get emails that contains, some unwanted links, right? Contains unwanted links rather. These links, sometimes they might be offensive and derogatory to a particular user, right? And which is not supposed to be at the time. So these are mails that are being classified as spammy emails. Sometimes you receive mails that contains a lot of, pornographic images, pornographic videos, and all of those. Or some emails that contain keywords like, oh, you've just won $1 million, kindly reach out to this particular email to claim your prize and all of those. So different attackers, different fraudsters out there are using this opportunity to take advantage of the vulnerable individuals that are making use of the email system, right? And sometimes some people, when they receive this kind of emails, they tend to fall prey for this kind of setups. And They deliver their credit cards information and all of those, and they get infiltrated. So in order for us to be able to stop all of this from happening, Gmail as an email system provider actually has provided a lot of machine learning models that are able to filter all of this. So most times when spammers actually send this kind of emails, you don't get to receive them on your major inbox. Most times you go to your spam and you receive them. Sometimes you also see some normal emails going to your spam. Why basically is because they actually have some attributes of being a spammy email, and the algorithm does not really care if that email is actually coming from a reputable person. The moment it detects that it has that one particular attribute that looks spammy, it will take it there, especially when emails have a lot of links, hyperlinks in them. So it automatically flags this kind of email. So what do we mean by labeled data basically? Just like I said, you need to feed this model with different data or different examples of different emails so that the model will be able to learn that, oh, whenever I see a spam email, I know it's a spam email. Or whenever I see a normal email, I know it's a normal email, right? So what do you do at this point? You give it examples. You give it so many examples of spam emails. You give it so many examples of normal emails, right? So that it will learn from these emails. So what we are doing basically, we are giving it data, right? But we are labeling the data. The model knows that this particular data example we are giving it is spam. It knows that this particular one is normal, right? So in the future, right, whenever a new email is coming to your inbox, for example, this new email can come, right? Some can be spam and some can be normal, right? The moment your ML model actually detects that it looks like one of the examples you've given it before, right? Remember, you've given it examples of spam, examples of normal, right? So when you're giving it new ones, right, it looks like, you know, a spammy email already. So it already knows that, oh, I've once learned that whenever I see these kind of emails with so kind of attributes, I'm being taxed to be able to flag it as a spam email. Or whenever I see this sort of email with this sort of attributes, I should flag it as a normal email. So this is what we mean by labeled data, right? And most times, most machine learning models that make use of labeled data are called supervised machine learning models, right? So this is what supervised machine learning models is. So in a real world example, I just give an example of spam filters, right? That's supervised machine learning models, right? What other example can I give? For example, okay, we'll get to that. That's detection anomaly, that's fraud detection and all of those. But we'll get to those basically. We could also have, just like I explained earlier, we have examples of a meal, right? We have you cooked a meal or you give a machine learning model some set of ingredients, some set of instructions, right, to prepare a meal for you, right? So what you are doing there is what you are doing there basically is that you are telling the machine, this is the machine learning model, you are telling the machine that, oh, okay, take examples of different food that have been cooked before. Let's take this off. All right. So we are telling the machine learning model, this is the machine learning model basically, and we are saying that, oh, okay, the kind of data we are going to be giving you this time around will give you data about ingredients, right? We'll also give you data about how to cook this food, and we'll also give you an example of what the food looks like, right? So you have an example of what the food looks like. You have the list of instruction on how to prepare this food. You also have, a list of ingredients that would enable you to, prepare this food, right? So the machine already knows that this is a set of ingredients, these are set of instructions, and this is what is the output, the preferred, or the preferred output rather. So we have the preferred output. We also have set of instructions, right? And we also have the list of ingredients, right? This is the list of ingredients. This is the preferred output. This is the set of instructions, right? So we are giving it all this information, and you can see they are all labeled because it knows that, oh, okay, these are the list of ingredients. These are the set of instructions. This is the preferred output of how our food should look like. So that in the future, right, after this machine learning model have learned from all these different examples, in the future, when you give it, right, like a new food, for example, and say, oh, determine what I need to do to cook this food, all right, it already knows the list of the set of instructions and the list of ingredients that enables someone to prepare this kind of meal, right? So it helps you determine all of those. So that's how supervised machine learning works, basically. So let's go on to what unsupervised machine learning is. Let's take this off. All right. So now moving on to unsupervised machine learning. And what is unsupervised machine learning? As you may have guessed already, it's just simply the opposite of supervised machine learning, right? So in unsupervised machine learning, situations where you feed your machine learning model with the data, you don't feed them with labeled data, you feed them with unlabeled data. So what the machine learning model does is basically it checks or learn from the patterns within that data, right? So a quick example that would make you guys understand is, say for example, I have a blog, right? This is a blog. I have a blog, and on my blog, I have different visitors on my blog. Different people are visiting my blog. Different people are reading my blog. People of all ages, people of all races, people from different time zones. People read blog posts at different hours, different seconds and minutes, right? So in this situation, basically, if you were to be asked, determine the number of older people that read your blog posts, or at what time the most younger people read your blog post, for example. So in this situation, the machine does not have or does not know about this different set of peoples, right, that read your blog post. So what it does basically is that it checks, this is how it works. It checks this is like maybe a list of people that reads your blog post. So what your machine learning model does is that it checks all this list of people, right? And it groups them according to their likes, right? So maybe it groups this set of people, it groups this set of people, and it says that maybe this set of people, they usually read my blog posts at 5 p.m. every day, right? Then it also checks this group of people and maybe notice that this group of people actually read blog posts very early in the morning, right? These are the different categories of people that the machine learning model has actually grouped, right? But similarly, when we try to train this particular machine learning model, it does not learn from labeled data. Why? Because even ourselves, we can't determine what are the kind of people that read this particular blog posts, at night, or what are the kind of people that read blog posts early in the morning and all of those. So we cannot give the machine learning model examples of this kind of people. It's not like, oh, the people that read blog posts at night are people with reading glasses. We cannot explicitly determine that, or we cannot conclude, right? Anybody can read a blog post at midnight. Anybody can read a blog post in the morning, and all of those, right? So in this situation, we don't have so many examples to give the machine. We cannot tell the machine that, oh, if you see this set of people, just know that they are the ones that used to read blog posts at night, or if you see this set of people, just know that they are the ones that used to read blog posts in the morning. We cannot determine that because anybody can read blog posts in the morning. Anybody can read blog posts in the night, right? So in this situation, we would give the machine learning model a data, right? We'll give it data, but the question is that what kind of data are we giving it this time around? We are giving it unlabeled data, right? We are just giving it data of all the people that are reading the blog post. Everybody that's reading the blog post, we are giving this machine learning model, and we are saying, oh, take and learn from these people, right? Take and learn. This is our machine learning model, for example, and we give it a list of everybody or data about everybody that is reading this blog post. So do you know what it does to this particular data? What it does basically is that it groups them, just like I explained a few minutes ago. It groups them. This is the list of people that are reading the data, right? It groups them. It checks in for pattern, right, within the data. It checks in for pattern within the data, and it notices, right? It learns over time that as if this set of people, this particular set of people, they always read the post at night, right? At night. Or this particular set of people. No, this particular set of people, they always read in the morning. They always read in the morning, right? So that's what the machine learning model does. So instead of you giving it examples of people, it's the one that actually goes out there to understand what people likes, right? A quick or a sweet example of how unsupervised machine learning model works is on YouTube, for example, right? Or let's say, yeah, on YouTube, for example. So on YouTube, for example, if I watch maybe sport, for example, I watch sport all the time, all right? And maybe MEC watch, entertainment videos, entertainment videos all the time. And Oluwaseun actually watches reality TV shows all the time, right? You know, what the YouTube algorithm does is that it already knows that, oh, me, I like sports, Yemisi likes entertainment videos, and Oluwaseun likes reality TV um, shows, right? What the YouTube algorithm does is that it starts to look for similar people that does the same thing as you. For example, I watch sport, right? It will go and look for maybe the next 1 million people that love the same sport that I used to watch, right? It will also know the different kind of people that used to watch entertainment videos like EMC. The algorithm will also know the different kind of people that watch reality TV shows like Oluwaseun, right? And it will group them together in one place, group them together in one place, group them together in one place, right? And anything that the YouTube algorithm wants to do, it can now easily take action, right? Maybe it groups everybody that is watching sports like this, everybody that's watching entertainment, everybody that's watching reality TV show, right? Maybe inside this place we have like maybe 1 million people or 1 billion people, 1 billion people that are watching entertainment around. You know what it does? It then starts suggesting, right? So people that are watching sports to start giving them sports related content. People that are watching entertainment, to start giving them entertainment related content. People that are watching reality TV shows, start giving them, you know, reality TV content. So that's how YouTube algorithm works, right? So sometimes you'll be surprised that because I watch sport today, tomorrow you now start seeing, or I watch sport like for 2 days on YouTube. Tomorrow you now start seeing that YouTube is recommending sport for you all the time, and all of those. All of these things they change, right? If you notice, sometimes when you stop watching that sport for a while and you're watching something else, you notice that YouTube will still be suggesting another thing for you that you've watched recently. How does this happen? It's because anytime the model is working, it will regroup you again, right? Maybe you notice that after 2 days you are watching reality. Maybe me that I'm watching sports before. EMC is watching entertainment. Oluwaseun is watching reality TV show. What if maybe tomorrow or for the next 1 week I started watching entertainment? Do you know that the YouTube algorithm will carry me from this group, right? This entertainment group, and it will put me in EMC's group because he noticed that recently in the past 2 days or past 4 days I've been watching, entertainment. And if, for example, Oluwaseun for the next maybe 1 week or 2 days or one day self started watching sports, right? It will regroup, it will carry Oluwaseun from this group and bring Oluwaseun back to sports group. So you now notice that you now be seeing more sports, you know, um, sport related content. And these algorithms can act very fast. Sometimes you went to shop on AliExpress, for example, you went to shop on AliExpress and immediately you just enter Instagram, you just see one ad that is showing you that same thing that you went to search for or you went to check on AliExpress. That's how this unsupervised machine learning works, right? And it's the same thing ad system is using. All these ads that you're seeing, that's the system they use. Ad system, right? That's the system they use because they group different people that want the same thing and they show them the ad. So if you are somebody that is watching that likes maybe hair products, skin products, and stuff like that, you see that you're only seeing ads about skin because the algorithm, the ad system has already recognized that, oh, you're part of the people within Instagram that is will visit a lot of skincare pages. Maybe you used to buy a lot of organics and all of those. You know, it already identifies you. So that's how ad systems work, right? YouTube works and all of those. In YouTube case, you call them recommendation system. In ads, you call them recommendation systems too, right? But all of this is working on one particular algorithm. We used to call that algorithm clustering algorithm. I know you guys will not understand it yet, but moving forward, you understand what clustering is. It's called clustering, right? That grouping that is grouping you guys is called clusters. They cluster you guys to cluster you, cluster, cluster. So that's basically how unsupervised learning works, right? Then the last but not the least basically is the reinforcement learning. So how does reinforcement learning works basically? Reinforcement learning basically is the ability for you to be able, you know, to train agents, right? So this is what I mean. For example, you have a dog, right? You have a dog. I don't know how to draw a dog, but let's manage this. Right, this is a dog, right? And you have somebody that is the dog owner. This is the dog, and this is the dog owner, right? So this dog, what is it meant for? Sometimes some people actually have their dog as pets, right? Some people have their dogs as security agents, people that animals that can serve as security for them, and whatever reasons you might have your dog for, right? So if maybe a thief is coming to your house, right? Most times you see some dog, they will start to bark, right? They will bark and bark and bark until the owner calls for help. Maybe the owner will call the security, or the owner would, do something, and they would apprehend the particular thief at the time, right? But what if a situation comes and your dog did not bark? Usually it used to bark when you see thieves, right? And usually it does not bark. What happens in that situation? Remember, when your dog sees a thief and he barks, right? And you're aware that, oh, there's a thief at my gate, let me call the police, something like that. At the end of the day, the police comes and they catch the thief, right? What do you do as a human being? You reward your dog now, right? You give it maybe big, big bones, give it big, big meat to eat that day, right? And you reward it, and your dog will become happy, right? Because you've rewarded it. And next time, because of that reward, that big, big meat you gave your dog, next time when you see more thieves, it will shout better, right? Because he knows that at the end of the day, if he if he performs better, you're going to give it more meat, right? But in a situation where he sees a thief and he does not immediately recognize the thief, maybe he does not recognize the thief and he thinks, or maybe he thought that it was one of your friends, and at the end of the day, the thief entered your house and robbed you. You will be angry at your dog. You would shout at your dog. You say, what kind of nonsense is that? Why do you not bark? Stuff like that. And you can even decide to punish your dog and not give it meat that day at all, or even food. Your dog will stay hungry overnight. Why? Because your dog was supposed to just do one jump, that is to bark when you see people that you don't recognize. But the dog did not bark, just stood like that and started looking until the thief entered your house and stole your stuff, right? So you punish the dog, basically. So this is how reinforcement learning works, right? This is how it works. It works in a situation where your machine learning model, you don't give it labeled data, or you don't give it uh, unlabeled data. In fact, not all the time you give reinforcement learning data. It's the one that will generate data for itself, right? So this is your machine learning model, right? And they are saying, oh, the only thing you are giving your machine learning model is to do is you are giving it some set of tasks, right? Perform these tasks for me. Just like the way you bought your dog and you're telling your dog that anytime you see somebody that is unrecognized, back, right? So what you are doing to this machine learning model, you are giving it tasks to do, right? So the more it does the tasks correctly, right, you are giving it a reward. You're giving it a reward. And the more it does not do the task properly, what do? You're giving it a punishment. You're giving it a punishment. So how does this work in the real world, right? You guys know that we have robots these days that do a lot of fantastic things, right? Some robots are intelligent enough to be able to serve you meals in a restaurant. Some are intelligent enough to work for the military and, identify the bad guys. They are able to handle guns and all of those. Different robots we see these days. In fact, in a mall in Dubai, we now have a robot that stands as a police, right? They are scanning everywhere. They understand your intentions as a human being. If you have some sort of characteristics of somebody that wants to steal something or is suspicious, the bot will actually alert the police and the police will come and parade you away from the mall, you know, and all of those. So in the case of a bot, a robot, for example, right, you know, we understand that these robots, they are subject to fail sometimes. They can fail sometimes, right? So that's why we use reinforcement learning for them, right? Because we don't give them static data because they are learning like human beings. And once they are human being, right, nobody needs to tell you some things all the time. You gain experience as you live life, right? The way you acted to some things 10 years ago or 5 years ago is absolutely different from the way you respond to things today, right? Why? Because life has taught you a lot of lessons. You've gained a lot of experience about some things. So you now understand, right? Same thing as a reinforcement agent, right? That's the major reason why they allow them to act like human beings, right? We only program them to act like human beings so that the more they do things, right, the more they understand, the more they gain experience, right? Just like the bot or the robot I told you guys about in the Dubai mall, right? The more people it catches in Dubai mall that either wants to steal something, the more it catches people, the more it gains experience. If you go and check that bot in the next or that robot in the next 2 years or 3 years, it has learned a millions of things already, right? In fact, maybe if he even sees you from afar, he already knows that you have a eye of a thief. Maybe, I don't know if that's going to be possible, but I'm telling you how intelligent this robot can be, right? So that's reinforcement learning. So in situations where that particular robot maybe mistakenly went to apprehend the wrong person in the mall, maybe the person did not steal anything sef. The boss just went to misbehave and went to catch the person or inform the police. And at the end of the day, they found out that the person is guilty and all of those. You know what will happen? The bot will be automatically punished. That means they will minus rewards from the bot, right? So if you are giving for every successful apprehension, we are giving the robot plus one. Anytime that the robot fucks up, right, you give the robot maybe like minus one, right? And once you give the robot minus one, the robot will get angry, seriously. And the next time it will perform better, right? So the more the merit is getting, the more better is getting performed, right? Moving forward. So that's how reinforcement learning is. And you see all of these things within robots and also many other artificial intelligence solutions out there, basically. So yeah, we've been able to cover what machine learning is, the different categories of machine learning. You know, we talked about supervised, unsupervised reinforcement learning, and all of those. So moving forward, we'll quickly talk about the use of pandas and numpys to process data. Basically, I'll be walking you guys through the assignments. You don't need to worry so much about the talk contact section because I'll give you resources that will help you understand the second contact session better. And with the second contact session, you'll be able to attempt the assignment for the third contact session. So, what are pandas or what are numpy basically? If you guys could remember correctly, I made mention of data exploration as you know, part of the data science lifecycle. And we explained that with data exploration, it enables you to better understand your data, right? So, and I also mentioned that there are tools that enables you to be able to explore data. And one of those tools basically is pandas. And we also have NumPy and sometimes sci-fi, right? So pandas is specifically used for data manipulation and data exploration, right? We also have NumPy that is able to handle numerical data properly, right? So maybe, for example, you want to deal with a lot of data types that includes integers, float, or numerical values, basically. NumPy is the best tool to use at that point in time. If you also want to go further to compute some advanced calculations or scientific calculation, that's where you make use of sci-fi, right? You can literally do all kind of computation there, right? You can do a distribution analysis, you can calculate regression, you can do whatnot, right? Any mathematical arithmetic you can think of can make use of sci-fi to orchestrate those mathematical calculations, basically. So let me just give you guys a snippet of pandas, right? And how it works, right? It's a very cool library to make use of, basically. So let me give you an example. Hmm. All right, so this is me making use of pandas, for example, right? I'm trying to work on some data, right, and perform sentimental analysis on those data, right? So how do I even make use of this data, right? How do I check out the information in this data? How do I use the information in data? So say, for example, you're given a CSV file, right, and some other kind of file, and they told you that, oh, open this file and use the information within a particular column to perform an analysis. How do you do so, right? So pandas gives you all of these different fantastic methods rather to be able to, you know, get into open this particular file, describe the file, explore it, and all of those. Excuse me. So those are the basic things that pandas enables you to achieve. So you might not have that time to actually walk through pandas from start, but pandas actually works on what we call data frames, right? So data frames are just a particular kind of architecture that we use in saving data, or pandas actually make use in saving data, right? It enables you to be able to create one-dimensional data structures and two-dimensional data structures, basically. So yeah, you'll be rest assured that you could have your data being structured in all kind of dimensions, right? You could do other things like, describing the data, um, value counts, you know, dropping off columns with missing data, in placing data into columns, and all of those and many more. So yeah, I'll also be giving you guys resources on how to get started with pandas and and NumPy basically. So yeah, then there's also one other resource I would like to share, which would give you guys like a basic implementation of some basic machine learning models like decision tree, random forest, you know,
extreme gradient boosts, and it will also teach you on so many steps in order to optimize your machine learning models, right? Um, Parameter hyper tuning and all of those. So yeah, that's basically it for this particular contact session. You know, machine learning, its categories, NumPy, sci-fi, and pandas, basically.
So yeah, just like I said, for the other contact session, you will be doing things that are related to classification models and clustering, basically. Well, not to worry, and you'd be able to understand these particular concepts properly with these we've just discussed and the resources I'm going to be sharing, basically. So you guys can hop onto this particular website called Kaggle. So Kaggle is like the home of data scientists, where you have billions and billions of data sets there for you to make use of. You also have um, so many experts in the field that are contributing to open source projects. You and they've actually collated some basic fundamentals of machine learning that every beginner could always start with. All right, so I'd always recommend this for you to start with. Moving forward, it will enable me to be able to better explain technical concepts on machine learning. So we have cargo slash intro to machine learning. Mm, okay. All right. So it wouldn't take you too long to work on this particular intro, right? It works. I think you'd have to. It's just 3 hours, and not necessarily up to 3 hours. It comes with an interactive shell or a sandbox. So this particular sandbox actually enables you to um, have a programming environment, a data science environment where you have all of the dependencies already. So you don't need to worry about, installing pandas, numpy, scikit-learn, all of those things, basically. I think I have very slow network. But I don't know the reason why it's not coming up. But I'm going to be sharing a link to that basically for you guys. You guys can always go there and start off the course. It will give you all of the insights as regards the technical aspect of this particular topic. So you could always build on whatever you've learned from this particular intro machine learning course. You can also check the Slack channel. I dropped the link to the course there, basically. And I'll also be dropping resources on how to get started with pandas as well. So at this junction, do we have any questions? Let me see if you have any question. Oluwasham.
Uh, Good evening, sir.
Yeah, really.
Well, thank you for today's session. So, um, about the scraping of the website that you told us to do,
Yeah,
the question asked to scrape also the rating, like those star rating on the
mm,
site.
yeah,
I'm having an issue with getting that particular star rating because After inspecting the code, I didn't see anything per se that I can use to target that particular that particular area. Sha. That's the only area
Oh,
I'm
okay.
having. Yeah, the
Mm,
rating part. I
yeah,
didn't know
okay.
how to get it.
Mm. So in for the rating part, basically, I know for sure that that's for books to script, right?
Yes, sir. Yes, sir.
Yeah. So for book to script, the rating part is not, you cannot really extract the information from that object. So what you do in that situation is just to extract the immediate class, right?